guys? I'm Nathan,
I'm Qasim.
and today we're going to teach you how to play
tennis.
with physics. It may seem like this motion is very simple, but a lot is happening in that one motion. But don't worry, listen to our tips and tricks, and you'll be serving like a pro in no time. Let me break it down for you. The most important part about the serve in tennis is the toss. If your toss is not good, neither will the serve be. The serve should be tossed about twice your arm length above your head. As the ball moves up in the air, its velocity decreases because of the unbalanced force on it. Then, when the ball's velocity is 0 and the ball is stationary in the air, then you start your serve motion. When you swing at the ball, you first start by swinging upwards. Then, as you make contact with the ball, you finish your motion by swinging through the ball and downward. That way, the ball will go into the box not just because of the force of gravity, but also because of the force from your racket. The faster the acceleration of your racket is, the greater the velocity of the racket, increasing the momentum in your swing. This large change in velocity is what causes the great amount of force on the ball. When the racket hits the ball, this momentum transfers to the ball, increasing the amount of force on it. And since the large transfer of force happens in a short amount of time, the impulse is extremely large. However, keep in mind that the more force you put on the ball to make the serve faster, the less control you have. So, no need to be too reckless on your serve. That's enough about the serve. Let's move on a bit further into the game.
Once you hit the serve, you're going to need to know how to keep the ball going. I'm going to walk you through one of the possible shots that you might need to hit. The forehand!
The forehand is a shot that is used a lot by all tennis players and needs to be perfected if you want to be good at tennis. Let's go through the physics behind the forehand and how to implement it in your game. Before you go into the actual swing, let's talk about the physics of the ball coming towards you. When a ball is coming towards you, after your opponent hits it, there are two forces acting on it: the gravitational force and the air resistance. Generally, the ball will be traveling towards you and a little towards the ground. The air resistance force will act on the ball opposite of its motion, and the gravitational force will act straight down towards the earth. Using this, we can draw a diagram and see that the net force on the ball is facing to the right and down. This means that the ball is speeding up downwards and it is speeding down to the right. This tells us that the ball will speed up to the ground and get closer as it reaches you. Now that we know about the forces and acceleration of the ball when it's in the air, we can move on to the ball's motion when it hits the ground. The ball, when it's in the air, has momentum. We know this because it's moving and it has mass. When the ball hits the ground, it comes into contact with the ground for a very small amount of time, and then it reverses its downward velocity. The ground exerts a large force on the ball, causing it to change its velocity rapidly. We can draw a momentum bar graph to represent this. Looking at just the momentum of the ball, we can use the impulse equation to show the force from the ground, time in contact with the ground, and change in velocity of the ball. Now, after the ball hits the ground, it has the same forces acting on it, but the velocity of the ball is in a different direction. This means the air resistance is also moving in a different is also facing in a different direction. Now, moving on to the actual swing. Before the ball reaches you, you want to bring the racket back. You could also bring the racket up to help with timing and get more momentum. Bringing the racket back allows the racket more time to accelerate before you hit the ball. When the ball is starting to get in front of you, exert a force on the racket, bringing it forward. We can see the forces acting on the racket with the force diagram. As you can see, the net force of the racket is to the right. This means that the racket will accelerate to the right. You want to time your racket to hit the ball when it is a little in front of you. Now, once the ball hits the racket, it will reverse its motion and start moving away from you. This is because of the force exerted on the ball from your racket and the momentum of the ball. The ball and the racket are in contact for a very small amount of time. The force on the ball is very large and the velocity of the ball reverses. We can use the impulse equation to show this. You don't want to hit the ball too fast or too slow. This is because if your racket has too much speed when it hits the ball, it will have more momentum and it will exert a larger force on the ball, causing it to have more momentum transfer to it and have a larger velocity after impact, which can make the ball go out of bounds. You also don't want to hit it with your racket going too slow. This is because if your racket is too slow, its momentum will be smaller, which will transfer a smaller amount of momentum to the ball and exert a smaller force on the ball, which will cause it to have a smaller velocity after impact. This can cause it to go into the net.
That was a lot about the forehand. And with a little practice, you'll be playing with gusto.
And soon you'll be playing just like this.
Oh wait, no, we should record a video of us scoring. With physics.
You didn't do the thing. Alright, just start recording. Oh my god. Redo. Nah, that wasn't good. That was Oh my god. It may look like a lot is happening in this motion. Oh my god.
After you hit the serve, you're gonna know.
Oh.
Once you hit the serve, you're gonna need to know. What are the possible, or no, I would say possible strokes that you could hit that you might. Oh. Once you hit the serve, you're gonna need to how. Wait, the four. These balls are so dead. It hit a crack. That was a lot about the four. That was a lot about the four. But soon, well, and with a little bit of practice, no.
No.
Yeah. Oh, yeah.